Right now, let's quickly dive into example 3. So, example say 3 is saying find the limit by calculating. So, let's do some calculations here. So, we have this example. So, let's look at number 1. So, for example 1 is saying limit of as x approaches 2 of 5x minus what? Minus 3. So this is equal to, so what is this means what is x, you put what, a 2, so it will be 5 2 minus 3. So 5 multiplied by 2 is 10, so it will be 10 minus 3. So 10 minus 3 is equal to what? 7. So it means you have solved this function. So let's go to example 2. So this one is limit of 3x plus 4 over x plus 5 as x approaches negative 2. So where there is x, you place negative 2, so it will be 3 of negative 2 plus 4 over negative 2 plus 5, so is equal to, so 3 times negative 2 is negative 6 plus 4 over negative 2 plus 5. So negative 4 plus negative 6 plus 4 is negative 2 over. So this is negative, this is positive 3, negative 2 plus 5 is positive 3. So as simple as that. Then let's move on to the last example here. So it's saying limit of 2x squared plus 2x minus 5 as over x cubic minus x squared plus x plus 1 as x approaches 3. So as usual, there is x, you press 3. So let's go 2 3 squared plus 2 3 minus 5 over 3 cubic minus x squared, plus 3 squared plus 3 plus 1. So 3 squared is 9. 9 times 2, 18, plus this 2 times 3, 6, minus 5 over 3 cubic, 27, minus 3 squared, this is 9, plus 3 plus 1, so is equal to, so you have 18 plus 6. So 6 minus 5, this gives you a 1. So 1 plus 18, this is 19 over. So 3 plus 1, this is 4. 9 minus negative 9 plus 4, this is negative 5. So 27 minus 5, this gives you a 22. So this is 19 over 22. Okay. Now let's go. Now we have solved this one. Now let's look at the laws of limits. So like any other things, if given limits of what have laws, so let's go look at the laws of limits. So let's go to our first law. So our first law is the identity rule. So if f of x is equal to x, then for any value of xo, so xo is any number, maybe it can be 2 3 4, any number. Then so suppose limit of x as it approaches xo of f of x. So we have been told to say if f of x is equal to what, x, so what is f of x, we place what, x, so it goes to as limit of x as it x approaches a certain number is equal to xo. Yeah. So for what, for any identity, so suppose x is our identity here. If we replace it with any number, this same number which we replace to next will be our answer. So suppose you have limit of x as x approaches 3, the answer will be a 3. That's what we call an identity element. So for an identity element, the value of x which we replace will be what, the limit itself. Yeah. Then let's look into our example, the second law. So the second law is the constant law. So if f of x is k, which is a constant, so if f of x is a constant, then for x is x, or so limit of f of x as x approaches a certain number of, so what we have been told to say, f of x is what, k, which is a constant. So limit of f of k as x approaches a certain number is equal to k. So a limit of a constant is the constant itself. when you go to differentiation of a constant was 0, but for this one, for limit of a constant, it's the constant itself. So suppose you have limit of x as it approaches 7 or 4. So the limit of 4 as it approaches 7, it's 4 itself. So you can't replace 7 in any function here, because if this 4 doesn't have x, so the x here is x to the power 0. So 7 to the power 0 gives you a 1. So 1 times 4 gives you a 4. So limit of a constant is a constant itself. So then let's go to our third law. So our third law is the sum law. So for a sum law, so if you have limit of x as it approaches a of f of x plus g of x. So f of x plus g of x is our, this is our sum, the sum now, where f of x plus g of x. So this is one will be equal to limit of x as it, limit of f of x as x approaches a plus limit of g of x as x approaches a. So for this one, for constant, you first have to find the limit of f of x, then you add plus the limit of g of x. Let's quickly go into our fourth law, which is the difference too. So the difference too is just the same as the sum law, just the sign which is different. So limit of f of x minus g of x as x approaches a. So it will be equal to as the same, it's the same as limit of f of x as x approaches a less limit of g of x as x approaches a. So for these two, only the signs are different. That's why it's sum and difference. Yeah. Then let's go to the fifth rule. So the fifth rule is the product rule. So let's look at the product rule. So for a product rule, so limit of f of x multiplied by g of x as x approaches a is the same as limit of f of x as x approaches a multiplied by limit of x, limit of g of x as x approaches a. So for this one, you have to find first the limit of f of x, then you multiply with the limit of g of x. You don't go there. First, you have to find them separate, then multiply them. Then let's go to the constant multiple rule. So the constant multiple rule is the combination of the constant rule and the product rule. So suppose you have limit of x of the constant multiplied by f of x of as x approaches a. So this one will be same as constant multiplied by limit of x as it approaches a, or limit of f of x as x approaches a. Since you have been taught to say, if we look back here on top here, for the constant, if f of x is a constant, so for a constant, the limit, any limit of a constant is what, a constant. So if we go back here, the limit of k as x approaches z is the constant itself. That's when then you are going to multiply it, multiplied by the limit of x as it approaches z of f of x. So you have to find the limit of f of x, then you multiply it by the constant here. Okay, let's go to our seventh and last law for today. So the last two is the quotient law. So for the quotient law, limit of f of x over g of x as x approaches z is the same as, is equal to limit of f of x as x approaches a over limit of g of x as x approaches a. So for this one, you have to find the limit of f of x, then we divide by the limit of g of x.